Hi everyone, welcome to the second week of your class on institutional research and assessment at Caldwell University. This week we are covering quantitative data collection and analysis. Now, fear not, you do not need to be a statistician to make it through the next week of this class. I repeat, you do not need to be an expert in statistics to go through smoothly the second week of this course. I wanted to make that clear up front, folks. The outline that we're going to cover in this particular slide deck, I'll give a quick overview and a refresher, just in general, of the class so far and a couple of the concepts that we've already covered. Then we're going to talk about quantitative data collection, and it's mostly surveys that we use on the quantitative side of the house. And we'll talk about some issues of whether or not you'll create your own versus using an existing instrument. We'll look at things like validity and reliability, whether or not surveys should be anonymous or confidential, whether or not we're going to use a population or a sample when we're comprising the folks that we're going to study. The next section we'll move then into data analysis. And again, you don't need to be an expert in statistics. I'm going to do a brief overview of descriptive statistics and inferential statistics with the goal that you come away from this class being able to read an assessment report, being able to read different statistical reports that you would find within the field of institutional research and higher education. Two quick things I'd like to mention before we dive into the content. First and foremost, I'm obviously using a different tool to record these slides, to record the narration on these slides, and I hope that this works well for you. If not, please let me know. I would love to hear your feedback either way on if this system works better than just narrating PowerPoint slides themselves or vice versa. Second, while I've created the vast majority of the slides that you'll see here, there are a few that I have borrowed from colleagues with their permission, and you'll see where I give credit where credit is due a little bit later on. So now we'll go into the core content that we're going to cover this particular week. What you see on the screen now is, of course, just a reminder of the simple assessment cycle that we covered last week, where you start at the top with your plans for the educational activity that you'll be doing. It might be a program for something outside the classroom. It may be a class. It may be a service, whatever it might be, whatever the object is that you'll be assessing. The second point is, of course, implementing that work, carrying it out, doing our jobs well. The third part of the cycle is then collecting data, and we'll discuss this week particularly the quantitative-based data collection, which is mostly numeric in nature. We'll get into a little bit of analysis this week as well. We're going to save the reporting part of the assessment cycle for a little bit later on in this term. And finally, the last step around the assessment cycle is the continuous improvement of the work that we do. That's the whole point, folks. We go around this whole cycle so that we have enough information to give it a good look and figure out, okay, well, what's going well and where else can we improve? What does it all mean? So in general, we're going to look at this is just an overview of the methods that we'll cover. And I mentioned just a minute ago that quantitative methods generate numerical data. So we are talking about different types of numbers that are used in different ways. And we use a variety of statistical procedures to interpret these data. And we'll talk about those when we get into the analysis section. So, there are different sources of data that we have. Sometimes we're just looking at already existing institutional records, like how many people are registered at your particular institution, how many classes are they taking, how many people are in each class, what does all of that mean? We use a lot of survey data, and we're going to talk a little bit about how to construct a survey as part of this week's discussion on the quantitative data collection. But we do other kinds of data collection as well, looking at different kinds of documents, scoring of different rubrics and portfolios. All of these things can involve numbers in some way, shape, or form, and we consider it forms of quantitative data collection. So what are statistics? And you can read this slide here. It's, we're basically referring to this range of techniques and procedures that we use for, eventually making decisions on data. So that's what that's the more broad term, and you hear it in the plural. Statistics is talking about this whole field. The second usage will be just a statistic. It's one numerical quantity. So, you might hear these terms used interchangeably, but typically statistics in the plural is used for the whole field of the study of these kinds of numbers to understand this type of information, whereas a statistic is a specific point on a report. The bottom line, these are the things that you need to keep in mind about this whole week, is that we are ultimately trying to look at the raw data that we have and put it into some kind of a summary view. We're transforming these things into some kinds of pictures or words. We're ultimately trying to explain the numbers into plain English so that we can all understand. You want to be able to accurately describe a particular situation so that, there can be lots of different interpretations of the numbers that we see. What our job is when we're reporting on these statistics ultimately, and I am talking a week or two now, from now, when we will get into the reporting, the ultimate goal is to analyze these things enough so that we can tell a story, so that we can report out on what we have and what the context is for what this means. We wouldn't want the data to just stand on their own. We need to be able to depict the context around it and why things might be happening. Okay, so like I mentioned a minute or two ago, one of the major uses of quantitative data collection is we're doing this through surveys. Sometimes we have a few other ways of collecting data, but we're going to focus a little bit on how do you go about planning to administer a survey. Now, I know that many of you maybe have never done this before, or you've done a survey or two here and there, but it's not something that you do every single day. My main advice to you is to seek a colleague for help. There are probably faculty or other staff at your institutions who have a lot of experience with the development of surveys. Developing survey items is a bit of a science. It's also a bit of an art. And it's an important balance to find, and so I highly encourage you to reach out to others. However, when reaching out to them, you may want to already have some of the answers to these questions. That will greatly help the people in either your institutional research shop at your institution, or if you don't have one, like I said, you can chat with some faculty members about some of these things. So, what do you or your colleagues need to know? Why do you need a survey in the first place? What's the main research question? What's the main point? And then, who is the target audience of this survey? Is it students? Is it a certain subgroup of students? Is it faculty or staff? Is it people in the community? Those first two things are crucial. And it may seem pretty obvious, but over the years, I've had several people that would approach that just say, well, I need more information on what I'm doing. I think I should administer a survey. And they haven't really thought through a lot of the answers to these questions. Will you use a sample? We're going to talk in a minute or two about the difference between a population survey and a sample of that population. Will you purchase an instrument? There are a lot of ready-made surveys out there ready to go. And sometimes it might be easier to just, instead of going through the trouble of finding a colleague who can help you write a survey, there may be one out there that already meets your needs. And you also have to think through who will actually do the data analysis and the data reporting. It may or may not be you, but if it could be the colleague that helps you write the survey, or it could be somebody else, or it could be a group of folks. Regardless, it's helpful to have all of these things answered before you start in the first place. There are several steps that we typically take when we are developing a survey, and the first of which is kind of like on the slide before. It's outlining your topic. It's what's the research question. And then start drafting out your items. Now, I just said, you might want to seek some help from folks that have done this before, but you know how to write. You know how to express your ideas in written form. Go ahead and try to draft some of the items. Create kind of an iterative process. You draft a few things, you share it with your colleagues, you go back and forth, and you do the best that you can with just the process of drafting and then ultimately writing and editing and rewriting the items as you can. The third bar on here, the third step about choosing response sets, is extremely important. So not only do you have to write the question, but then you also need to write the way that people respond. Is it going to be a scale of strongly disagree to strongly agree? Is it going to be a scale from very unlikely to very likely that the respondent would do something. So we're going to talk about how often they've done something. Oh, I've done this frequently, or really hardly at all, whatever it might be. It's really important to think about having a few different options for the kinds of response sets depending on the kinds of information that you're trying to receive as a result of administering the survey. And then determine the item sequence. So this is really, what's the order that you're going to be asking these questions? Sometimes you might want to start with demographics. You might want to say, what is your gender identity? What is your race, ethnicity? What year are you in school? If this is for students, whatever it may be. Sometimes we leave those items for the end. Sometimes we want respondents to be able to go right into the content first and then think about these things at the end. Sometimes folks will drop out of a survey partway through, and so the demographics aren't crucial, but they're really just something that would be good to know. Then we tend to put those things at the end. Other times we may put them at the beginning if they inform other ways of skipping around the survey depending on, how you might respond. So if we're asking women one set of questions and men another set of questions, we may ask for the gender identity question up front before having the respondents skip around to the different portions of the survey. Finally, you want to revise and review and revise and review the survey as much as you can. We always miss things the first time through. It's completely normal. So you want to make sure that you allow enough time, if you're writing your own survey, that to test it out, to review it, revise it as much as you can. Now, I skipped a step. I shouldn't have said test it out so soon. You have to revise it first. But then you do want to do a pilot survey. So that hopefully, if you're going to be surveying all students that are psychology majors, for example, you might want to choose one class of them and pilot your survey and get their feedback on it. Ask them some questions after they take it about how was the experience of taking this survey? Did it make sense? Were you able to proceed through it in a regular way? Did we miss anything? What do we still need to do to edit it? So this is not a short process. It takes a great deal of time. But if you plan up front and to try to handle some of these things on the back, but before you get too deep into it, rather, you will end up with a much smoother process. Now, I mentioned a little while ago determining the population, or determining whom we will study. Sometimes we're looking at studying an entire group. I know that at my current institution and the institution I worked at before, we did a couple of different population-wide surveys. Now, this is going out to thousands and thousands of students at the places where I was. They were pretty large. But the point was, in both cases, we were doing climate studies. We were trying to study different aspects of the climate. And when you're looking at the total climate, it's really best to do a population survey to give everybody an opportunity to weigh in. And it may be a topic like, what's the climate for race or ethnicity at this institution? You may have heard in the news that there have been many studies done on initiatives around Title IX or sexual assault education at colleges and universities. These are really important and rather difficult topics, and we want to make sure that everybody has a chance to weigh in. So it's, those are really great reasons to do a population survey, but they should not be done very often. We don't want to overwhelm our students with surveys in the field. So we try to use them just once in a while, and we try to coordinate this with an institutional research shop or another central shop that can help regulate the numbers of surveys that are out in the field. On the other side, when we're not surveying the entire population, we're just going to want a sample. It's just a subsection of that group. So we may want to survey, I mentioned psychology before, maybe we're sending a survey to every student that's taking Psychology 101 in a given year. That's kind of your basic entry-level psychology class. Maybe you're focusing on students that are members of a certain student organization group, like fraternities and sororities. Or maybe you're looking at faculty that are in STEM fields and you're trying to understand current trends that they are dealing with on a regular basis. Whatever it might be, it's really important up front to determine if you're going to sample just a subsection of the total population or if it's going to be a population study in general. Then another very important question to handle is whether or not it's going to be confidential or anonymous. And I know that those words can sound synonymous, but they're really not. Confidential survey means that we could identify respondents. So we tend to have some kind of an identifier in the data. It might be their student ID, if you're looking at students at a college or university. And you keep their ID with their responses. And, there are a couple of ways, a couple of advantages to this. First and foremost, you could address the letter that where we're inviting them to participate in the survey with a custom name, like in my case, Dear Rob. We would love for you to respond to this survey, as opposed to just Dear Student or Dear Professor or whatever it is. If you really want to customize some of the invitations to participate in the surveys, and you might want it to have a confidential survey so that you can identify folks up front. And that way on the back end, more important, on the back end, you're able to identify how many men responded, how many women responded, how many of different racial or ethnic groups responded to the survey. You may, when you are conducting analysis, you might want to be able to kind of slice and dice the data by the gender variable or by the race ethnicity variable. And you won't be able to do that in a reliable way unless you have it as a confidential survey, where you can add in these other background variables about your students to the raw data. This will make a little bit more sense later on. The other way to approach this is just have it be anonymous so that you're not able to identify respondents. So you wouldn't be able to, add in their demographic variables on the back end, and the invitation to participate may say, Dear Student. However, if it's a really controversial topic, especially like some of the climate surveys that I just mentioned, I think it's important to keep it anonymous. You really want to protect the student's identity so that even though we're able to identify folks who respond to a confidential survey, we don't. Okay? I mean, that's really important to keep in mind. We don't identify individuals responding to a survey. It goes against our ethics of protecting human subjects. We are able to, for the purpose of identifying groups of respondents. So that's how we use the data that are confidential. We're simply using them in the aggregate. We're never drilling down to the individual level. However, if it's a really controversial topic, we want to avoid any perception that we could be using somebody's data to hurt them. And so then it's important to keep it anonymous. This is a really important distinction to make early on in your survey construction process. Okay, next we're going to move on to the notion of reliability and validity. Those of you that are a little, have more of a scientific background, you may have heard the term, the psychometric properties of the instrument, and it's really talking about how consistent or reliable are the items in the survey, and then how accurate are they. And so, what you see here on the slide with reliability and validity, I love these definitions here. Reliability is the extent to which the test measures the same thing every time. No matter who is responding, no matter what the context is, it's a reliable item. We know that people will interpret it in the same way. A valid item, however, is the extent to which the test is measuring what it's supposed to measure. We want to make sure, if you want to make sure that you actually are collecting data on things that you need, that you're focused on, you want to make sure that it's valid. So let me try to explain this in a little bit of a different context. I have these 4 questions up on the screen that might help to illustrate a little bit better the difference between reliability and validity. The first one talks about whether or not respondents would interpret the item on the same way on a different day. So there may be something going on one day that's not happening the next, but is the question still going to mean the same thing? The second one is the item going to mean the same thing to all people in the population? So will a question mean something different to a junior or a senior in college versus a first year or a second year student in college? Are these things reliable throughout the entire time that a student is in college? That's a question that we'd ask around determining whether or not something is reliable. And then these last 2, talking about validity, will this item elicit the information that you actually want? And will it elicit accurate and relevant data? An example of whether or not an item or even an entire instrument is valid can be, looking at, sometimes we have students take a hearing test, especially in elementary and high school. Now, if the student for some reason isn't able to communicate verbally that they have heard a sound, or if they're physically not able to raise their hand. Remember when you've taken a hearing test, and if you hear something in your right ear, you raise your right hand, and if you hear something in your left ear, you raise your left hand. Well, if you're limited in your mobility, how are you going to communicate that you're hearing something? You may be hearing something just fine, but the way that this particular test is constructed, it's not a valid measure of hearing for everyone, especially if their movement is otherwise impaired. In other words, that kind of a test is not eliciting accurate and relevant data. So another way to represent validity and reliability is by looking at 3 different dartboards where we're trying to throw darts at them. So let me get the darts up on the screen. There we go. So the top one, you see that things are really spread all over the place. The second one, the darts are grouped in one spot, but it's not really hitting the bullseye there, right? And the third one down here at the bottom, that's hitting the target just fine. Well, let's talk about whether or not these things can represent data that are reliable or data that are valid, okay? So this first one up here where the darts are all over the board and they're not really grouped together anywhere, and they're certainly not hitting the bullseye, we would say that those are neither reliable nor valid. We don't really know what it's measuring. And it's not, it's not hitting the target, so it's not valid. But it's also not really consistent anywhere. It's not grouped anywhere. We're not getting the same kinds of responses. So it's not reliable either. Okay, now the second one, down here, what do you think that is? Where they're grouped in one spot, but they're not hitting the bullseye. Well, those would be that they are reliable, but they're not valid. So it's reliable because they're all answering something. You can tell they're all grouped together. So there's something going on there that's going well. But it's not hitting the bullseye. So this part means, well, it's reliable. It's doing something. We're measuring something, but it's not measuring what you intend to measure. It's not valid. Okay? You can have reliability without validity. So you're consistently measuring something, but what exactly is that? It's hard to tell. So then, of course, this third one is that, yes, they are both reliable and valid. All of the darts are hitting the target in one group, so it's reliable, and it's also hitting the bullseye of the target. It's hitting the center of it, so it's therefore valid. It is measuring what you want to measure. You can have reliability without validity, but you really can't have validity unless it's reliable. Unless all those darts are grouped together, there's no way that they're going to hit the target. Okay, so I hope that makes sense for now, and let us move on from playing with darts, as fun as it has been. So, one thing that is important to keep in mind when you're putting together a survey is to note the reason for each data point that you're collecting. So you need to keep asking yourself, why are we asking this question? Are you comparing the purpose of your study against the questions that you've asked? So just make sure that you don't have any gaps between the questions that you're developing and your actual purpose for the survey. Also, look for overlap. If you've got a couple of questions that are essentially measuring the same thing, just get rid of one of them. Keep it short. Keep it as simple as it can be. Give the respondents a break. I mean, we don't want them to get tired during the survey that we're administering. So we want to make sure that, we're just being as concise as we can be. Eliminate things that may be just nice to know. Like, it might be really nice to know if the students responding to this survey took this English class last year. Well, what you could do is just look up how many students took that English class, be able to provide a number in your report saying, there were 55 people in this class. Some of them may have responded to this survey. If it's just nice to know, I wouldn't ask it. If it's essential, then okay, go for it and say, did you take this English class last year? If you're noting the reason for each data point, it might help you with the ordering of the different items that you have. Sometimes they may be consecutive. You might need to ask one question before you ask another, and it may depend on the topic that you're doing. Just be real aware of the sequence that you're developing. And, be sure to retain the reasons why you constructed this survey so that you remember it for the analysis stage. Sometimes the analysis can be driven by the purpose, and it's important to keep these things in mind as you're moving through the survey development process. Okay? Next, we're going to get into the analysis of the quantitative data now that we've covered different points about data collection. So, oftentimes we can tell a really decent story by looking at what we call descriptive statistics, and it's pretty much like it sounds. We're simply describing what's there. Don't forget that one of our biggest tasks with a quantitative analysis is to reduce the number of data rows that we have and try to describe in a concise way. So we look at these things in order to help us do that. So measures of central tendency. This may bring back memories of a stats class that you took a while ago, where we're looking at the mean, the median, or the mode. So the mean is just the numeric average of a set of numbers. The median is the point in the middle. If you were to order all of those numbers from lowest to highest, the point in the middle is the median. And the nice thing about that is that 50% of the responses are above the median and 50% of the responses are below the median. Sometimes it's a handy thing to be able to share. The mode then is the single highest response for any one response option. So, you were administering a survey item and you had 100 people take it and the correct answer was C. And if C is the mode, that means that the majority of people got the answer right. They chose the right response, and it's therefore the mode, the highest response out of several different options on the survey item. And it's basically answering this question that you see at the end: what does the average person do or say or think? It's the measure of central tendency is looking at how does the majority respond to this item. Then we're looking at, this middle column, we're looking at measures of frequency. So how often are people responding in a certain way? You're just counting things up. You're providing the percent number of respondents to a certain item. You're looking at the frequency range, which is looking at an entire item to see, well, what percentage of the items of the persons responding said A versus B versus C or D. I'll have a few examples to share with you later on. It's basically, literally saying how many people are doing something or saying something or thinking something. So as the first one is looking at what does the average person do, measures of frequency is looking at how many people did it, regardless of if they're average or they're not average. And then the third section here is measures of dispersion or variance. So we're looking at the range of responses. So we may be able to calculate the average, but then we want to see, well, what was the range? What was the lowest response? What was the highest response? How much was that spread? So that, we're able to see how consistent things were. You may have folks that say, oh yeah, they seem really satisfied with this class that we just taught. But if the range is really large, if there are quite a few people at the low end of the scale and quite a few people at the high end, the average might be in the middle or might be doing just fine, but you're going to want to investigate, well, why is the range so wide? What does that mean? So these, looking at the combination of these central tendency and the frequency and the spread can help us describe a really nice story. So here's an example of different means from a survey that I believe was administered by my colleague at UCLA a few years ago. This is just simple perceptions of the campus climate. And you can see here this was a 1 to 6 scale, where we have friendly on the low end of the scale, and we have hostile on the high end of the scale. I'm talking about the first number on here. And for each of these, we have things that we tend to seek as positive, like friendly, caring, tolerant of diversity, safe, affordable. these things are a little bit more desirable in most cases, and we're rating them with a 1. Whereas the things that are not as desirable, like hostile, impersonal, intolerant, dangerous, not affordable, those are the negative things, and we're rating those with a higher number as a 6. Now, typically on surveys, we tend to code these things in the reverse form, so that if it's something that's more desirable, it gets a higher number, and if something that's less desirable, it gets a lower number. In this case, it's just something to keep in mind that this is like a golf score instead of a bowling score. I talk about that a lot with my colleagues. Is this golf or bowling? So some of you may not play either of those sports. In golf, you want a low score. The lower, the better. In bowling, you want a high score. The higher, the better. So in this case, this is more like golf. You want to have a low score. And so some of these means are pretty low. So the average response here for intellectual versus non-intellectual is a 1.98. Well, 1 out of, almost a 2 out of 6, it's fairly intellectual. Okay. The other score that's probably the more desirable on this list here, safe to dangerous. Well, that's pretty darn safe. It's down toward the 1 end of things, and 1 is safe, 6 is dangerous. A couple of the items that are higher, though, too academically easy or too hard, the respondents to this particular item said that, they're more right about a 4, so they're a little bit above the middle of this spread, middle of this range of response options. So it seems like that this climate it's pretty tough academically. You're getting up toward the higher end of this scale. So those are just different things to keep in mind as we're interpreting a set of means. You need to understand that the mean is the numeric average, and then you need to look at the scale and find out, is a 2.11 good, or is it desirable, or is it not desirable? It's important to work those things out first before you try to interpret this. So this is looking at the same set of means, but it's then putting them on a graph. Now, in this example, it's probably pretty tough to be able to understand it because it's what we call reverse coded. It might be nice to turn some of these scores around so that the more desirable ones have a higher number and the less desirable ones have a lower number, because you want the graphs to be representative of something that you might want as more desirable in this case. But nevertheless, we can interpret this. We can see that the highest score, in this case the less desirable, is the ease of academics. Students are thinking it's too hard, and that's certainly a lot higher than some of these other ones on intellect or safety. So just a neat way to represent the data, albeit I think it should be coded in the opposite direction. And then here we try to find the different stats. This is a typical printout from what's called SPSS, or Statistical Package for the Social Sciences. Don't worry, you're not going to use this package, this software, for this class. However, it's fairly commonly used at institutions of higher education, at least, especially in offices of institutional research, and so I wanted to make sure that you at least had a chance to see what a printout looks like. And in this case, you can see on the left-hand side, the left-hand column here, I'm going to try to point that out with the cursor, the mean and median and mode are listed over here, along with things like the standard deviation or the dispersity, the range, and the minimum and the maximum. So, if we're looking at this printout, I want you to be able to see where these different measures of central tendency are. So the mean for the first question, campus climate of friendly versus hostile, is right there, the 2.11. And then where's the median, looking at the one next to it, for being tolerant of diversity? That's the 2.00 right there. And then finally the campus climate, too easy academically or too hard. As we talked about before, we know that the mode there was pretty high at 4 out of 6. So the students are finding that pretty tough. But it's just helpful to see on this printout where these things lie. So now that we've seen a few examples of measures of central tendency, like the mean, median, and mode, now we're going to get into an example or two here of frequencies. This comes from a report based on data from the National Survey of Student Engagement that was administered at The Ohio State University in 2013. And here it gives a nice, pretty easy to read view of the first year respondents and the fourth year respondents of this particular survey at Ohio State. So you can see pretty quickly that, okay, well, 60% were first year students and 40% are fourth year students. That's easy to see. If you're looking for how many students were first generation, well, we can look pretty quickly right here, right underneath it, that in the first year students, 27% are first gen, and just under 33% in the senior class for first generation. If you're looking for where people live, at Ohio State, the majority of the first year students were required to live on campus, so it makes sense that 82.1% of the respondents were living in a residence hall. Whereas for the seniors, many of them were the mode response here, the mode of this, not really response, but the mode characteristic, the highest characteristic here is 69% for those living off campus within walking distance. So it's just interesting to get a pretty quick view of the different demographics that we have in a group of respondents to one particular survey. And now for another view of frequencies, we're looking at the same source, so it's still the National Survey of Student Engagement responses from Ohio State University in 2013. And now we're looking at how many hours per week did students participate in co-curricular activities. So we're looking at first year students versus fourth year students. And again, you can see fairly quickly that the highest number for each was 1 to 5 hours. So it's almost 41% for the first year students and just under 40% for the seniors. And, you can also very quickly see what percentage of students say that they're not participating in any co-curriculars at all. And it's a little smaller for the first years than it is for the seniors. And I guess that makes a little bit of sense that seniors may be more focused on their next steps beyond college and not spending a lot of time on co-curricular activities. It's a slightly higher percentage there. So interesting to see. And again, you can see it pretty quickly at a glance. That's a nice, simple frequency chart, being able to compare the first years with the fourth years kind of on the fly. One more example now to share on frequencies. This is looking at a different source of data, also found at Ohio State University. I used to work there, so that's why I'm bringing up a lot of these examples, and these are all available on their website. This is from the Multi-Institutional Study of Leadership, or the MSL, as designated in the lower right-hand corner. And this is looking at a construct called consciousness of self. And it's depicting that these that the scores on the consciousness of self scale differ by the race ethnicity of the respondents. So that for Asian students it was at 3.8, for white students it was at 4, for multiracial or black students, two different categories, it was at 4.1 for each. So it's interesting to see how those things vary based on the race or ethnicity of the respondents. And in the next few slides, we're going to talk a little bit about statistical significance and how these things may be significantly different or not from each other. It would be interesting to learn a little bit more about what's going on here in the data to figure out, well, why are some of these things different? Why is this consciousness of self construct different depending on the different race and ethnicities that we have in the respondents? Okay, so now we're going into inferential statistics. We're going to look at, are there differences among groups, the first thing, and then the second thing is, are different aspects of our data related to each other? So whether or not there are differences, we're looking at things like t-tests, ANOVAs, or chi-squares, and then whether or not things are related, correlations, regressions, factor analysis. Fear not, you do not need to be a statistician to get through this week of class. I know I've said that once before, but I wanted to just emphasize it again as we get into the more complex end of statistics. So first here you see an example of a t-test, the output of a t-test. And the question was, I feel that I belong on this campus. And what we found at Ohio State was that the first generation students responded lower on this item than the ones who are not first generation students in the bar on the left. And the asterisks here mean that there is a significant difference. Asterisks here, then we look at the interpretation at the bottom. The p-value is less than 0.01. Okay, so what does this mean in plain English? Look, statistical significance basically means that there is some kind of a difference between these two groups, and the difference is due to something other than just a coincidence. There's something going on in the data here that's driving this difference. It's not just by chance. And we measure the extent that we're confident about this by looking at the p-value. The more asterisks that you have, the more confident we are that these differences are due to something other than just being a coincidence. Okay? So in this case, we suspect that the first generation status may be driving students' sense of belonging. If you are a first gen student, this group of respondents tended not to feel that they belonged as much as the ones who were not first gen students. So, interesting to consider. Once again, significance is just saying these things are different due to something other than chance, and the number of asterisks that you see tells you how confident you are in that assertion that these things are different. Okay, so that's an example of a t-test. Next we go to an example of an ANOVA. ANOVA is an acronym that stands for Analysis of Variance. It is the same thing as a t-test. I'm going to go back a slide here. A t-test is an analysis of variance, but it is just for two different categories. In this case, non-first generation students versus first generation students. So that it's analyzing the variance between these two variables. It's a t-test. And ANOVA, now I've gone ahead a slide, is looking at more than two categories that we're comparing. So same idea as a t-test. There's something different here, but instead of just saying it's different between two categories, now we're saying that it's different among three or more categories. And we need to do a different kind of statistical calculation to get to the same conclusion as to whether or not things are different. I'm not going to go into the statistical calculation. What I am going to say, though, is that we can tell from this graph that we are looking at racial and ethnic categories, white, black, Asian, Latino, multiracial, and we're looking at these different questions. I have observed discriminatory words, behaviors, gestures directed at people like me. I have encountered discrimination, or I have worked with others to make this campus or community a better place. There are significant differences going on in here, and for the first item, this darker graph, we have two asterisks. So we are more confident, we are pretty darn confident here that there are some significant differences. And you look at the percentages, the white students are pretty low, black students are the highest group, Latino is the lowest group in this case, and others are in the middle in terms of I have observing discriminatory words directed at people like me. So there's a difference in there. There's another test that we can do on the back end called a post hoc test to determine where the differences are among the categories. I think we can kind of see it here because these are different, the responses are so very different. But nevertheless, I'm just emphasizing that a statistically significant difference is just saying that there's something going on there driven by something other than just coincidence that's making these things different. And in this case, it's one's race or ethnic identity. Then we go into correlations. And again, we're getting into instead of looking at whether or not things are different, we're now looking at whether or not things are related. And things can either be related and negative, or related and positive? You can see some of these scatter plots on the bottom. And similar to the darts that we were throwing on the dartboard a few slides ago, no correlation is just scattered. It's this graph on the right. Positive correlation is a sloping line upward and to the right, and negative is one that is going from upper left down to the lower right. And we describe these things with a correlation coefficient, and it's simply a number that is somewhere between positive 1 and negative 1. So the closer to 1 or negative 1 that you are, the stronger the relationship that it is. And, the direction of this relationship obviously is going to be determined by a plus or a minus sign. If you're close to 0, then that means that the correlation's pretty weak. The correlation coefficient, we use the letter R. So the R value, if it's 0, then you're going to have a scatter plot. If it's close to 1, it's going to be this one in the middle. If it's close to negative 1, it'll be the one on the left. And it's helpful to tell, as something increases, something else may decrease. That is a negative correlation when one increases and one decreases over time. When they both increase, then that's a positive correlation. And I've got a couple of examples to share on this next slide. So this comes from my colleague at UCLA. And again, we can measure the significance of these correlations, that there's something going on there, there's some kind of a relationship between two variables that is particularly strong, and it's different from relationships in other variables, and it's due to something other than just chance. Now, we're not sure exactly what that is. We could probably dig into the details of this particular survey and find out why. But let's just take a look at a couple of them here. So we look at the intersections of the columns and the rows. So concern about progress intersects with the row that's perception of progress. And that's a significant correlation. So, we say that, as students are perceiving that they're progressing on something, they're also concerned about it at the same time. These are both increasing at the same time, so it's a positive correlation. And point 38 is getting into the moderate range of correlations. Yeah, we didn't say that on this last slide. I went back a slide just to check, but we tend to say that 0 to 0.0 up to about 0.3 is small, and then you get above 0.3 to 0.6, and that's moderate. And then you get 0.6 and higher, and that's a strong correlation. And so this is getting into the moderate end of things as being a strongly correlated relationship between one's perception of their progress and their actual concern about it. And we can talk about each of the others, but I think you get the point that where these things intersect, in this case, all of these have positive and positive significant correlations. Some of them are less strong than others. Remember, the closer to 1 you are, the stronger the correlation. The closer to 0 that you are, the weaker the correlation. So one final note here before we wrap up this particular slide deck is that correlation never is equal to causation. We're just looking at a relationship here. There's really hardly ever, I don't think there's ever any kind of situation in using statistics that we can actually say that one thing caused another. We're really just looking at relationships, positive or negative, strong or not strong. So in this case, in this middle bullet here, we can say from that the slide, the previous slide, that there's a moderate positive relationship between perceptions of progress and concern about progress. Moderate and positive, but it's just a relationship. We can't say that your perceptions are causing your concern about your progress. That doesn't make any sense. And we can't make that claim. We can just claim that these things are related to each other. Okay? So I hope that this has made sense for kind of our walk through the quantitative data collection and analysis that one could do in institutional research. And keep these things in mind as you're reading the readings for this week and thinking about some of these concepts, and also starting to relate some of these ideas to the projects that you'll be designing for this semester together. Thanks so much.